Hello, welcome to part 3 of building a web app using ASP.NET Core 1.0, Aurelia, TypeScript, and Webpack in Visual Studio Code. My name is Raja Mani. I live in San Jose. I'm very passionate about technologies. This is my blog, opensource.netter.blogspot.com, and the video that you're watching is actually complementing the blog post in opensource.netter.blogspot.com. Prerequisites for this video is you should have watched part 1 and 2. You can find the link in the video description in YouTube under this video. I also have the part 2 source code link posted there. Let's see what's in this part. In this part, I'm going to be talking about Webpack, a module bundler, and then what are modules and how can you develop modules and use them in JavaScript and TypeScript. Adding a TypeScript class as an entry point. How to run the application using the bundle.js generated by Webpack from Visual Studio Code, and then wiring the awesome TypeScript loader into Webpack. Let's jump right into the demo. As a prerequisite, you need to copy the part 2 source code into the part 3 folder. I've already done that. So on the right side, you can see my commander. I've already changed my directory to c:/tutorial/part3 modern. The first thing we want to do is to install Webpack. I'm going to be installing the latest version of Webpack, and that will be done using the npm install command with a --save-dev, because Webpack is only a development time dependency, not a runtime dependency. As soon as this Webpack is installed locally, what we'll do is we'll talk briefly about modules and why modules are there and how long has it been in existence. The concept of modules has been there for quite some time in JavaScript and are implemented using the libraries CommonJS and AMD, asynchronous module definition, were and still are very popular module standards before the standards body has finally defined the syntax and semantics for modules in ECMAScript 6. When it comes to module, you just need to remember two things: export and import. Export is used to export a module, and import is used to import a module into a JavaScript or TypeScript class, so you can use them. The ECMAScript 6 defines two kinds of exports: named exports, which means you can export several symbols. When I say symbols, it's nothing but a variable or a function or a class. And default imports implies only one symbol per module. TypeScript has support for modules for quite some time. Since TypeScript can transpile to JavaScript and it can transpile to any module formats like CommonJS or AMD or ES6, it's not a problem. So let's launch Visual Studio Code now. Let me dock it to the left side, and then I'm going to zoom it by pressing Control plus a few times. And as soon as it's loaded, we'll look at the folder structure. The first thing that we want to do is to take our greeter class that we wrote in part 2 and export it as a module by adding the keyword export. There are two ways to export a class. You could prefix the class definition with the word export, or you could define the class and then at the bottom you could always say export curly brace greeter. Both this syntax do the same thing. One is very easy and straightforward because you're defining it right there at the definition itself. The other one is after the definition, and it also allows you to export multiple modules. Say, for example, if I have another module named foo, I could export another module named bar. Since I have only one class in this file, I'm just going to export greeter. Then, what is the advantage of exporting a module? The purpose of exporting a module is for it to be consumed from another TypeScript class. We don't have another class. We only have one class named greeter.ts. So this is where we're going to be talking about the entry point class. For example, if you've done some programming from C or C++ or Java, you know there's a main method and that's the entry point, and any class that has the main method defined is an entry point. So the concept of a main or entry point is nothing new. It's been there since the days of C. When it comes to JavaScript or TypeScript development, people use the convention like app.js or main.js as the starting point of any application, and from there they do the necessary initialization and initialize or bootstrap frameworks like Aurelia, AngularJS, and so on. Since in this particular part we're only going to focus on Webpack, I'm not going to be talking about anything other than Webpack. So let us create a file named main.ts, and then let's import this greeter class and see how we can use them. So I'm going to add a new class named main.ts, and the first thing you want to do is import the greeter class. Import curly brace, name of the class, and then you have to say from the path of the module, which is going to be greeter. You don't need to give the extension .ts or .js. You just need to say import greeter from the name of the file without extension. That's more than enough. Instead of sitting there and watching me type, I'm going to just copy and paste the code that I've already written, and I'll explain that. Okay, so I am defining a class, and I'm exporting that as well so that it can be used from another module or another class. And it's a very simple constructor that creates an instance of a greeter class. And then I have a method named sayHello, which is just calling the greeter.sayHello and also store the value of the greeting message into the DOM. Then I define the greeting message accessor, and it just calls greeter.greeting message. At the bottom of the class, I am creating an instance of main class, and I'm calling the sayHello method, and also I'm calling console.log with that greeting message property. So that's a simple entry point class that is importing another module, and it demonstrates how we can call the imported modules methods and accessor. For now, just ignore this green squiggly. It's only a TS-lint warning saying that there's a trailing white space, so it's fine. Okay, now that we've defined the entry point class, we need to transpile these two classes, main.ts and greeter.ts, into JavaScript. And as you know, in the previous lesson, we knew that there is a command called tsc-w for watch, which will watch on the current folder, and then it'll transpile whatever is in the folder. So compilation complete. Let's double check if we have the output generated under the app folder. There we go. It generated greeter.js and main.js files. As you can see, it uses a module loader syntax, require, and it uses the same syntax like the path of the module. Okay, is that enough? TypeScript, we defined the type of the module loader or the type of the module that it should generate in the tsconfig.json over here. We mentioned that the target has to be ES5 class and the module has to be CommonJS format. But that alone is not enough because, like I said earlier, even though the ECMAScript has defined the standards, the browsers are yet to implement the module loader or module loader API. So we're still dependent upon the third-party libraries. Like there are quite a few implementations, like there's a system.js implementation, require.js implementation, Node has its own implementation of CommonJS, and Webpack also has a module loader. Since we're going to be using Webpack as our module bundler, and it already has module loader, it makes total sense for us to use Webpack to load our module and consume that from the application. Okay then, so how do I consume it? Let's go to index.html. If you see that in the previous lesson, we had directly added the generated JavaScript file using the script source. That's exactly what we want to avoid. We do not want to be including any file, but we need to somehow bootstrap or somehow let the HTML know that here's my starting point, here's my entry point JavaScript file. Go ahead and load the modules in that file, and then from there, find out the dependencies and keep on loading the other modules. So that part is still not done. We're not there yet. So how do I do that? That's where Webpack come into the picture. Let us open up another tab in Commander. Like I already opened 3 tabs. So I'm going to click on the second tab. I already used the second tab. So I'm going to go back to the first tab and let us see how you can bundle the generated JavaScript files from TypeScript into a single bundle file. Webpack command is very easy. You type Webpack, you give the source files. The source files are going to be in the folder www.root. Sorry, it's going to be in the source app, and our file is called main.js. Then the output file that I want to generate needs to go to www.root/app. Let me double check if that's the folder structure. Yes, that is our folder structure. We want the generated file to be called as bundle.js. You can name it anything you want, but I just want to call it bundle.js to indicate that it is a bundled file that contains the source code of main.js and its dependencies. If you look at main.js, we know that we imported the greeter.js as well through the import keyword in TypeScript, which was transpiled into a require common JS syntax in JavaScript. If you want, you can go take a look at that. If you go to main.js, the first line is use strict, which is to indicate that JavaScript uses a strict compilation mode. The second line is where you say var greeter1 equals require dot slash greeter. What does this allow us to do is we do not have to explicitly give dot source slash app slash greeter.js explicitly. If you give an entry point file, and if that entry point file loads the other modules, and if that dependency loads another dependency, Webpack can go ahead and detect all those dependencies and bundle them together. So let's hit enter and let's keep the Explorer open so we can see the bundle.js appearing there. Okay, so let's see what's going on. We are inside the modern folder, which is right here. Okay, so let's do a directory listing. We can see the source file. Okay. Oh, sorry, because what happened was I was looking at the source app where I only have my TypeScript files, not the generated files. So it's very easy. We just go there, use the up arrow, go there, and then change the path. Both our generated files and the bundle will be in the same folder, www.root/app/main.js, and hit enter. You will see the bundle.js appearing right there. So this file is a massive file. It combines all the files and bundles them. And don't worry about it. In production, you'll not be using this. You have an option to minify the files, but for development, it's okay. So as you can see, you only gave the main.js as an argument, but it smartly figured out that main.js is dependent upon greeter.js. So it bundled both of them and created a single file. Okay, then now what do? We go to index.html and then we refer that file, bundle.js, and we no longer need this. Why did I delete it? Because if you noticed, the main.ts file itself creates an instance, and it also calls the methods say hello, and it also logs the greeting message. Inside of the say hello, if you see that I am actually getting the DOM element with the ID greeting, which is going to be the div, and I'm just setting the inner HTML to h1 and the greeting message, which is going to be hello world, because I passed world as the argument to the constructor of greeter. So it's going to be hello world from TypeScript. It's going to display that. Since I have a console.log, again calling this property, which is also going to display hello world from TypeScript. So you're going to be seeing a h1 tag rendered inside the browser, and in debugger tools window console, you're going to be seeing two hello world from TypeScript message, one from the main class, another one from the greeter class. Okay, let's go ahead and run it. To run in Visual Studio Code, you need to hit F5, or you can go to you can click on this button, debug button, and then click on this green play button. Let's see if it launches the browser, opens up a tab. As you know, since it is using ASP.NET Core and we wired MVC, it's going to by default always go to home/index. And we can always give the index.html explicitly to load it. Before I hit enter, I want to launch the debug tools or developer tools by hitting F12, and then you can I'll just make some more space, or we can maximize it. That will be much better. Okay, so we can have the network tab as well as the console opened. Okay then, so now I hit enter. Let's see what's going to happen. Okay, there seems to be a problem. Let's figure out what's going on. But before that, I just want to show you the network tab. If you can see, the index.html is loaded, and that loaded bundle.js, which has the bundled source code for main.js as well as the greeter.js. Okay, let's expand this and see what's going on. Main.ts, it says cannot set property of inner HTML of null. I know what's going on. Let's go back to the code. This is just the ordering problem. So what we should have done is we should have gone to the index.html. We want the element to be available in the DOM before accessing it. So all we need to do is just take that script source from the header, head tag, and then push it right above the body tag, closing body tag. And now let's go back and hit F5 again. I haven't stopped the debugger, so the Kestrel web server is still running. So if I hit refresh again, if you want, I can clear the console and then hit refresh one more time. Okay, like I said, you're going to see hello world from TypeScript h1 tag rendered inside the browser, and you're going to see hello world from TypeScript from console.log, one from greeter and one from main, which we explicitly called. So this is all well and good, but this is still not good enough, because at the beginning I told that there is something called awesome TypeScript loader that can be used inside a Webpack that can handle this transpiling. So we no longer have to run this explicit watcher command tsc-w. So what I'm going to do is I'm going to bring in the awesome TypeScript loader and wire it into the Webpack configuration. Before I do that, I just wanted to stop this watcher. We no longer need it. I'm going to close this tab. And now we're going to do everything from within Webpack. Before we do that, as always, you need to install anything that you need as a dependency. So I'm going to run the npm install for the awesome TypeScript loader, and it's also a development time dependency. So it's going to be npm install awesome TypeScript loader -- save -dev. So let's hit enter, and it's going to download the awesome TypeScript loader. So far, we've been doing Webpack followed by the source file names and followed by the bundle name. That's fine, but Webpack has so many command line arguments. So if you type Webpack and hit enter, you can see, or you can type Webpack -- help, and you can see how many command line arguments are there. It's kind of hard to remember that, and you don't need to pass in everything as a command line argument. As you have seen from the part one of this course or this series, everything in JavaScript, they either pass command line arguments or they give a configuration file, like a file with an extension .json or .js. So for example, npm uses package.json, ASP.NET Core uses project.json, and many other tools use their own, like TypeScript uses tsconfig.json. Similarly, Webpack has its own configuration file, and the name of the file is webpack.config.js. Let's go ahead and create a webpack.config.js. Let me switch to Visual Studio Code, and we always want to create such configuration files at the root of the project so that it can look at all the other folders and it can perform operations on all of them without having to define them in a subfolder, then later having to redefine them in every single folder. So it's always a good idea whenever you want to have some configuration files, put them at the root of the project. So let's create a simple webpack.config.js file, and then we will go visit the GitHub page of Awesome TypeScript Loader, and they've already given what they want to do, how the loader should be configured. So let's save some typing. Let me first create the file, and then we'll go to the GitHub page, webpack.config.js. Okay, and let's hide the Explorer. Let's go to the Chrome browser and type awesome dash TypeScript loader, which I already have in my search cache. So I'm going to click on that GitHub page. And if you scroll down to the readme.md file, here you go. They have a nice webpack.config.js file that explains that shows how you want to configure your loader. Let's copy that and paste it into our webpack.config.js. Okay, so Webpack config.js has a module.export syntax. It just say module.exports, and then it gives a configuration file, configuration setting in as JSON. For example, here the resolve means what all extensions should this Webpack look for. Here we are mentioning that if no extensions or .ts or webpack.js or web.js, try to resolve all these extensions. And then the dev tool is a setting where you want to define whatever development tools you want to configure. In this case, we want to configure the source map, so it will be useful for us when Webpack generates one single bundle.js. You want to have a bundle.js.map so that you'll be able to troubleshoot or debug from within the development tools. I'll tell you how this affects our tsconfig.json and how that should be modified very shortly. Then the last one is the module. Then you have the loaders underneath that. You are going to be mentioning what loader you wanted to load. You wanted to match anything that ends with .ts, which is TypeScript files. They should be loaded using the awesome TypeScript loader, which we just downloaded using npm install. So this is the trick. Like this, there are so many other loaders that comes with Webpack, or there are several people, communities actively writing many loaders. For example, if somebody wants to use Sass or less, and then they want to convert that into CSS, they could use a Sass loader or CSS loader or less loader. Similarly, if somebody wanted to use ES6 or ES 2015, they could use the ES6 loader. People could use Babel loader. There are plenty of loaders available out there. For this demonstration, we're only interested in the TypeScript loader. That's awesome TypeScript loader that we downloaded. So is this enough? Absolutely not, because there's one more entry that is missing, which is the entry point. Like I said, we need to let Webpack Webpack configuration know where should it start the bundling, or what is the entry point of this application, from where should it start the bundling, and how to batch them together and bundle them together into a single bundle file. Of course, Webpack allows multiple entry points as well, but for this demonstration, I'm going to stick with a single entry point. So I'm going to copy the source code that I already prepared. I'm going to paste it over here. As you can see, I'm going to format it so it's readable. And here we go. Here I say my entry point is going to be www app main.js. Wait a minute. We wanted the awesome TypeScript loader to transpile the TypeScript code into JavaScript code. So this doesn't make any sense to me. Now I can mention my source file, or the entry point file, as source app main.ts itself, because we are no longer going to run the tsc-w, watch for changes, and compile it or transpile it. We're going to let the TypeScript loader to do that job for us. That's cool. So we have an entry point done, and then we need to tell Webpack where should it write the output bundle. This underscore underscore dir name is a node.js variable, which implies the directory from where you are running this webpack config.js. Plus, I wanted to go into the www root slash app. That's where I want to store my bundle.js. And that's it. And now, since we have the configuration file, we no longer have to pass command line arguments to Webpack. If you just type Webpack and hit enter, it's going to read through this config.js and then follow the settings or variables or properties that you set here and then act accordingly. But before we do that, I wanted to delete all these files because I no longer need them, because we're going to let Webpack create them again. And you will not see a greeter.js and main.js because Webpack is going to transpile them using the awesome TypeScript loader and bundle them. So you're going to only see a bundle.js inside the app folder after I run the webpack command. Let's go and run the webpack command now and hit enter. That's an interesting warning. It is a very standard stuff and we can easily fix it. Like I said, we need to make some changes to tsconfig.json. This is one of the changes, and there's another change which I need to make the source map work. So instead of waiting and watching that, I'm going to press Ctrl C to end that. Let us open up our tsconfig.json file. When we were practicing TypeScript in part 2, I let it generate an inline source map. Now I can no longer use that because I don't want to have an inline source map. I'd rather have one source map generated for the bundled JS file. So I am going to take this inline and then change this to source map equals true. When you have source map, you cannot have anything inline. So I'm going to delete this other entry. So that will make TypeScript happy. Sorry, the Webpack happy. Otherwise, it'll think that it's a contradiction because you want to generate inline source map, but in Webpack we mentioned the dev tool as source map. I don't want to waste time on that, so I'm just going to let it generate a source map file. And then the next one is this warning. It says you have resolved globes. Globe is just a wildcard where you can say a folder name slash star star slash star dot star or star.js, star.ts, whatever. That wildcard is called a globe or globe. Since we have resolved globes enabled in awesome TypeScript loader, we have to have an exclude directive, otherwise it's going to be very slow. Because in TypeScript, if you don't give an exclude, it means that compile anything and everything that has the extension .ts, which is not very efficient. So I'm going to copy this line and hit enter to copy that to the clipboard and paste it here. Since we are not using Bower, which is another package manager, we're only using Node. Whenever we run Node install npm install dash dash savedev, it's going to bring all those dependencies and store them in a special folder called node underscore modules, which we shouldn't be including as part of our TypeScript transpile process. So we exclude that folder. That'll make the awesome TypeScript loader happy. And this line will also make Webpack happy because now we want to generate a true source map, not an inline source map. Okay, then with those changes, let's hit the command Webpack and hit enter. Okay, watch that. As I told you, it's going to generate two files, bundle.js and bundle.js map. This is the file that is generated using Webpack. Webpack used the awesome TypeScript loader to transpile this greeter.ts and main.ts into the respective JavaScript files and then bundle them together into bundle.js. This is all controlled by that webpack.config.js file. And there we also mentioned the dev tool as source map. So it also generated the source map for us. So we could debug, we can put breakpoints in Chrome DevTools. Okay, then now that we have nothing has changed in index.html. It's the same thing. The only thing that we did was instead of us doing the tsc double dash w manually and then loading the bundle.js and running webpack commands with arguments, we removed everything. We centralized all of our processing like transpiling, bundling everything into a central file called webpack.config.js. So now we don't have to launch the debugger because as you can see, I have the debugger still running because we didn't make any changes on the server side. That is, we didn't make any changes in controllers or views. It's perfectly fine. All that we did was only make changes on client side, JavaScript, TypeScript, and HTML files, which can, if you go to the browser and if you hit F5, it's going to work. So let's go to the browser now and let us go back to the previous tab, clear everything, and do an F5. Everything worked just fine. The only difference is now Webpack is doing all the magic for us. That concludes this part of the series, folks. In the next part, I will be showing how to set up Aurelia framework from scratch and kickstart a new project using Aurelia's TypeScript Webpack skeleton navigation project as the foundation. Until then, happy coding. See you later.